I call Bernardo Mota.
Good morning, everyone. I'm very, very, very happy to be here. And I really am thankful to Karin Schema and to Ladislav Kvas and to David Rabois and to Ariel Zermaki, who was very helpful, for having invited me. I'm truly happy to be here with Professor Eberhard Knobloch. I'm really, it's been a long time since I've seen some of these people, and it's like returning to see old friends. So I'm really happy, and I really appreciated that you invited me. They were very generous as well. They placed me in this part of the meeting, and my presentation is a lot more humble. I'm in the wrong session probably. But I'll try to show you what I've been doing throughout these years. So I was in Berlin under the supervision of Professor Knobloch, studying topics in the philosophy of mathematics in the 16th and 17th centuries. And while I was there, I was trying to study manuscripts of Portuguese mathematicians as well, from the same period, of the 16th and 17th centuries. And this took me the years from 2012 to 15 or something. And then I moved to the history of medicine. So for the past 5 years, I've been studying manuscripts and printed texts of Portuguese scholars who are Portuguese physicians. So they study medicine. These Portuguese scholars, mathematicians, philosophers, or physicians, actually left the country at some point, and they, we can find them living all over Europe. So we have Portuguese physicians and mathematicians living and teaching in Italy, in France, in Germany, and in the Netherlands, and so on. So it's very interesting to study these scholars because they give us a perspective of European scientific culture in the 17th or 16th centuries. So I chose to speak here of one of these scholars, Francisco de Melo, because he allows us to speak of Lisbon, of Paris, and, of Portugal, of France, and of Germany, all in the same talk. So I'm going to speak about these commentaries, on Euclid's optical treatises in the 16th century. And because he's unknown, let me show you who this person is. So Francisco de Melo was born in 1490, and he died in 1536, so he died pretty young. He actually studied in Lisbon, but then he moved to the University of Paris here. And here he learned philosophy and mathematics and theology. And he also taught on these subjects here at the University of Paris. He was staying at the College of Montaigu. We know that he was here from 1513 to 1520, more or less, because we have information on his staying by many authors. So his professor of mathematics, who was Gaspar Lattes, a Spaniard, wrote this Arithmetica Speculativa, this speculative arithmetics, which he dedicated to the generous and very erudite Sir Francisco de Melo. And we know that besides Gaspar Lattes, he was also taught mathematics by Pierre Brissot, and so on and so forth. Now, when he was staying in Paris, he taught on the elements of Euclid and on the optical treatises of Euclid. This is the Optica, the treatise on optics, and the treatise on catoptrica, the treatise on mirrors, and also on Archimedes. This he did before 1520. Then he moved to Lisbon in 1520, And afterwards, he became director of the University of Lisbon, so he was actually director of my university. Then he was elected a bishop of Goa, but he never went to Goa and never was a bishop anyway, because he died in the meanwhile. Now, this commentary, we have them in two copies. One copy of this commentary is at the Lisbon, at the library, the National Library of Portugal in Lisbon, and the other one is in Germany. So let me show you, let me speak about this commentary. So let's talk about the contents, and then a little bit about the characteristics of this commentary, and then let's conclude. So I'll start, I will begin by showing you the contents of this commentary by looking at copies, at our copy of the National Library of Lisbon. We have this copy. We know that this is a late copy of this text, and it was probably done in the end of the 16th century or in the 17th century at some time. This is done on paper. So what we have is four objects in this manuscript. We have a first part of the manuscript, which is about the theory of vision, so the theory of vision, and the form of the eyes. That's the structure of the eyes, or the anatomy of the eyes. This is the corollary. He means that this is an introduction to the optical works of Euclid, and Francisco de Melo says that he did this introduction himself. This is a very small treatise of about 20 folio. Afterwards, after this introduction, then he presents his commentaries on the perspective of Euclid. This is the optics in 35 folio. We have lots of diagrams, 100 diagrams for this part of the text. Then he moves to the treatise on the catoptrics. This is the treatise on the mirrors, which in several parts of the manuscript, he says that these commentaries are dedicated to the King Manuel of Portugal. The King Manuel died in 1521, so he must have given a copy of this to the king before that date. This must not be the copy he gave the king, of course. And in this page, we see what text he's using as a basis for his commentary. He's actually relying on an edition of Euclid printed by Bartolomeu Zamberto. The first edition is of 1505. And so immediately afterwards, he's commenting on the Euclidean text that he has printed by Bartolomeu Zamberto. And after this commentary on Euclid, the manuscript has a small treatise on the book of Archimedes of bodies that fall into humans. This is the famous text that speaks about the crown in the tub and so on and so forth. Now this is a very small part of the manuscript. It has only 8 folio, and it was translated in Paris by Pierre Forcadell. So we know that around 1565 there was a manuscript in Paris that Forcadell used for his translation. Forcadell never acknowledges that he's translating the text of Francisco de Melo. But we know it because we have the text of Francisco de Melo. Now, this text was edited by Marshall Clagett in a famous work, Archimedes in the Middle Ages, and his assessment of Francisco de Melo is in this sentence is very interesting. He says that Francisco's performance was quite impressive. He's referring to the text on Archimedes only, and not to the text on optics. Now, there's something interesting that happened while I was in Germany. So I was working with this text that we had in Lisbon, the one that Marshall Clagett knew. And what happened was that in 2012, the National Library in Lisbon received a contact from the Library of Berlin saying that they were in contact with the archive of Stralsund in the north, and they had found a manuscript which was probably from Spain or Portugal, and they were looking for information about it. And they actually, what they had was the original manuscript that Francisco de Melo offered to the king. This was an extraordinary coincidence, because we were working on the text, and the original text appeared in Stralsund, Germany. Now, we know this is a very different text. It looks like a printed text, but it's actually a manuscript. I'm ending at 11:15.
Yes.
So we know the story of the manuscript, and it's really fascinating. So Francisco de Melo had a copy made and offered to the king in around 1520. The king dies in 1521. So this manuscript was kept by the cosmographer of the king, this Luis Pimentel, who lived in the 17th century. At some point, he offers it to the Marquis de Lich, a Spaniard. This was a diplomatic offer. We don't know much about it. But then this Marquis dies, and the text was bought in Madrid by a Swedish diplomat, this Spangenfeld, who took it to Sweden. Now, this was then he died. The text was acquired by the Prince von Löwen, and then he died, and it ended up in the Stadt Archive of Stralsund. So the text was bought in Paris. It was copied and offered to the king in Lisbon. Then he went to Madrid, and then it ended up in Stralsund, which apparently was Swedish at the time. If this is not something that unites all the countries in this conference, I don't know what could. And this is why I chose it, because this is really, this is what I felt that I did throughout the years, to participate in a network that unites France, Germany, and Portugal. So there's a long tradition in Portugal for this things. So this is the same text that I showed you, but in the manuscript that appears in vellum. This is done in vellum, a very peculiar type of parchment. So you have here the theory of vision, the vivendicazione, and the structure of the eyes, but readable. You have here the perspective of Euclid, the catoptrics of Euclid dedicated to the king, to Emmanuel Lusitanorum Rege, and the treatise on the things that fall into liquids by Archimedes. This is a wonderful copy. The part related to Archimedes was actually after in 2015 was published, the translation and edition and a commentary by German scholars. And then in the same year in Portugal, I and Henrique Leitão edited the whole text, including the optical treatises. Now, let me point out some characteristics of this man. What is it that you find there? So I'm going to speak about philology, mathematics, and then I will conclude. You can see the difference between the manuscripts. So it helped a lot discovering the text of Stralsund. Because in some points of the manuscript in Lisbon, the ink corrupted the material. And so we could not read the text exactly. And whereas in Lisbon we had we were struggling to read the text, then it was actually readable and it was very easy to edit it. Now this is misleading because when you look at the manuscript, you think that it is correct. You look at this and you think that the text is perfect, and that's not the case. That's not the case. Diagrams are missing, or they are incorrect. Labels in diagrams are incorrect. The text is not correct, although it appears to be correct. and some passages are obscure. This will be, well, for those of you editing like this will be common every day. This is common stuff. So things very elementary, like convertantur doesn't have any meaning, connectantur. So you want to link or to connect dots and not to convert them. Or you have to read campano, the translator, and not campaurit, which is not the Latin word. So probably this erit here, which appears here, the manuscripts have some ink there. So this is trivial. More interesting is when something like this happens. The text here is perfect. It has no mistakes. You can read it. But it has lots of mistakes. So actually this is misleading because you trust the text, but you should not do that. Why? Well, because if you look at it, you have the word paralelo intervalo, but below you have paralela intervala. One of them is wrong. You have inequalis, which sometimes appears abbreviated, and it may mean in aequalibus angulis, in equal angles, but it may as well mean inequalis, different, unequal. And so sometimes in the text, this is difficult to understand. And sometimes you have letters which are labels, so this BA or AF are labels here, AF, but this AB is the preposition of oculo. Sometimes, here it is easy to read it like this, but sometimes it is not. Now, more interesting, you find the diagram perfect, and you try to make sense of it, but it doesn't make sense. You have double labels, for instance, and you cannot interpret the text. The person drawing the text also could not understand the text. So you have an IG, which is not in this diagram. The person drawing the diagram tried to draw it again. He added a G here, but also a G there, so you have two I's. And the diagram is incomplete. Actually, the diagram is cancelled. The person drawing the diagram actually cancelled the diagram because it's wrong. And he tried to paint it again, but again it is wrong, but this time it didn't do anything. This is an offer to the king. The text was done already, and he's drawing the diagrams afterwards. He made a mistake, and he does not want the king to notice it. It's a very expensive book to copy all over again. So let's do nothing. And so what you have is a beautiful text, but it has lots of mistakes of this sort. Now this is the philological part. There's the interesting part is related to mathematics. What is Francisco de Melo doing? What is he doing? Well, he's actually putting in practice the humanist way of practicing mathematics. Sorry for the term. So he's looking at the text. He wants to have a perfect text, but he wants to have the mathematics completely right. So he has one text of Euclid, and he eliminates what he thinks is not mathematically sound. For instance, in the Catoptrica, he eliminates three postulates because people are not comfortable with them, and he thinks they might be wrong. He adds corollaries or lemmas. He transforms the text of the demonstrations, and he adds citations from the elements, from other works of mathematics, so that the argument is complete. So he clarifies the deductive structure. So let me give you an example. I will have to shorten my example a little bit, but it will be enough. So the first proposition of the Catoptrica, of the work on mirrors, is one very simple proposition, very elementary. which says well, not in flat, in plane mirrors. So in plane or straight, in plane, convex, and concave mirrors, this is the mirror here. This is the mirror convex, this is the mirror concave. So in straight, convex, and concave mirrors, visual rays, this ray here, reflects at equal angles. So this is the visual ray, this is the reflected visual ray, and he's just stating that these angles are equal here again and here again. This is very simple. This is what you have in Euclid. Actually, I can show it to you because you have it here. It's the text in Euclid. This is the edition of Zamberto. Has 3 paragraphs, very small paragraphs. One related to straight mirrors, another to convex mirrors, and another to concave mirrors. It's very simple. Now, the proposition in Francisco de Melo occupies lots of pages, So he has, sorry, not this one, this one. He has one lemma before the proposition to draw a plane tangent to a given sphere at a given point, and he explains how to do it. He then, after the demonstration, has a first corollary. If a line is tangent to a circle or a sphere, it will make equal angles on each side, and he demonstrates this. He has a second corollary to state that in plane mirrors, the perpendicular rays from the point of reflection, that's the point C, bisects the angle formed by the entire ray, this ray and the reflected ray. This is very interesting. I cannot explain it. If you can help, that would be great. The diagrams are repeated, and sometimes this is very rare. In the first diagram, the line is in black. This is very rare. He has 2 or 3 examples of lines in black, and then he duplicates the diagram with colors. This was probably an essay or a test, I don't know. Then he adds a third corollary, and I will skip the other 2, otherwise we will stay here. You have 2 visual rays, this visual ray is here. This one here in red, and this one here, propagate from the eye, this is the eye, on different objects, these are the objects, in different planes. So you have to visualize the figure. You have 2 planes. The perpendicular lowered from the eye to the underlying plane will be the intersection of the planes, and so on and so forth. Nothing of this is in Euclid. He's just adding to explain the proposition. And he adds a lemma, and he adds a corollary, and so on and so forth. Which leads us to the humanist program of mathematics. So what is his purpose in all of this? And this we can take from the preface. In the preface he says, I worked with this clear purpose, that nothing would be absent from these books that could be missed to understand Euclid. He wants to explain every principle, every axiom, every premise, every step in the argument. He wants to bring it to discussion. So he wants to complete the text. I also did not wish to ramble excessively. I added many things necessary for those things that will be presented next, but that he separated from all others, so that the divine writings of Euclid would not be contaminated. So he wants a perfect text of Euclid, not contaminated, but he wants to add things until it is complete in the mathematical sense. And he wants to do this, and he is self-aware of this contribution, because he wants to add his name to the demonstrations as interpreted, not to the text of Euclid, but to his text added, so that his contributions could be more easily distinguished from those of others, and our zeal to the Republic of Letters be acknowledged. So he wants to participate in the Republic of Letters, which by this time was more or less like we have it in the slide. So these are the printed editions of the element. These are examples, but the first ones are these. This is just an example in the 16th century. these are the first printed editions, and what I wanted to show you with this slide is that Francisco de Melo's contribution is very early. It's a very early contribution. So he's writing in 1520 or 1515 or something like that. Let's skip this. These are examples of well, we have time, so we can actually show this. Giorgio Valli is a very important humanist, as known. If in 1501 he has this work, this encyclopedia on knowledge, and at some point he has the text of the first proposition of the Catoptrics. Very, very brief demonstration is included. The text of Zamberto, which Francisco de Melo is using, was published in 1505 and then republished several times. So this is the text that Francisco de Melo is using. And this leads us to the final conclusion that I wanted to show you, taken from the text of Francisco de Melo. So Francisco de Melo is trying to apply this humanist project to mathematics. He wants to have clear texts, but a full mathematical explanation. And then he says this explicitly at some point when he's trying to prove the first proposition of the Catoptrica that I showed you. The proof presented of this theorem, I have restored it. I have explained it more extensively, conjecturing as much as I could from what remains of Theon, because they thought that the text they had was a version of Euclid made by Theon in the 4th century. But since it is based on the second postulate of Euclid, he's referring to a postulate of the Catoptrica that he left out, which is not readily accepted by everyone. We thought of another demonstration of this theorem, not less elegant and by far easier than the one presented. To explain it, we will first prove, etc. So this is what he's trying to do. He's trying to rewrite the proofs, and he is trying to complete the proof by adding all the principles and lemmas and corollaries that he may add. So what's done? What's done? We have a full edition of the text. We have a full translation into Portuguese. There are a German translation of the work on Archimedes, and the edition as well. The work in progress now is to have a commentary on the whole commentary of Francisco de Melo. And this is it. So this is the references. I thank you very much.